Three disks, one metal with a gap, and one insulator, are dropped through a horizontal magnetic field. So a magnetic field that's going, say, into the board or out of the board. In which order do they land? And explain why. So our answer here has to do with Lenz's law. So which will land first? The one that will land first will have no resistance to its falling, and that'll be because there are no currents in it. So which of these can't hold any currents? That's right, the insulator. So the insulator will land first. We can't get any eddy currents in it to resist the falling, which means that it'll land first. The one that will land second is the second disk in this image. Now in this case, we won't get very many eddy currents forming. We'll get little circles appearing like this, and this, and this. And so we won't get very much resistance, but we'll still get more resistance than if we had just an insulator that couldn't carry any currents. Alright, so what about the last one? Well, obviously it's going to have to land last, isn't it? So the solid metal disk will land last because the eddy currents in this will be very, very large because they can go all the way around the disk. So that means that this will be able to support the strongest currents, which will produce the most resistance from its falling. So that means that the insulator will land first, the metal ring with a gap will land second, and the solid metal ring will land third. In fact, the eddy currents produced in the ring with the gap in it are usually so small that there's no real noticeable difference between the insulator and the metal with a gap. However, there is a significant difference for a metal donut that's completely is continuous, like this one, or even one that has no hole in the middle.